Alright, here we are with square and cubed roots, EI Lesson 5. The goal of this lesson is to use square and cubed root symbols to represent the equation of the form x squared equals p and x to the third equals p to estimate non-perfect squares. The idea is that we're going to estimate squares using information from the last lesson. Okay, so let's do the first problem here. What is sketch a square with an area of 25 square units. So here's a square-like shape anyway. And if the area is 25 square units squared, what must the length of each side be? Well, we know area of a square is side squared. So area is already given to us, 25. We'll plug in 25, substitute 25 for a, and that's equal to s squared. How do we find the side? Well, we're going to square root both sides. In this type of situation, just like we did in the last assignment, we'll need to apply a plus or minus because we've square rooted both sides to get plus or minus 5 equals s. Question, does negative 5 make sense for a side length for a square? Probably not unless it's a negative square, which doesn't usually make sense. So our x is going to be the positive 5 value. Positive 5 what? Square units. Square units. Okay, looking at number 2, the square root of 81. There are two numbers, actually, that make that true. That is positive 9 and negative 9. Don't forget your plus or minus. Whenever there's a square root, there's going to be a plus or minus going on. Okay. To solve for x in x squared equals 121, we square root both sides. The square root cancels with the square. We're left with x equals plus or minus, because you square rooted, 11. If you don't know that, I actually have this handy dandy square and cube table right here, which we will reference for this lesson. A lot of math kind of assumes that you know these squares and these cubes, at least for the first few cubes, and the squares all the way to 20 oftentimes. They'll just assume that you know it, and I think that's rather silly, but we will work on it in order to appease that silly assumption. At this point, you do have mostly enough information. After we've done number 4, I suggest you pause this video and do the rest on your own without my help. If you need help after that, go ahead and watch the video. All right, the square root of 50 is between, well, first of all, the square root of 49 is 7, and the square root of 64 is 8. The square root of 50 is just slightly larger than the square root of 49. So I'm going to guess it's maybe 7.07 or so. Let's plug that into our handy dandy calculator and see what it says. Square root of 50. Would you look at that? Surprised, maybe I've done this a few times. 7.07 is the square root of 50. We don't need a calculator to know that, though. The question is only asking what numbers it's between. We're going to say it's between 7 and 8, because it is. All right, what whole number is the closest approximation to root 90? Well, root 81 is 9, and root 100 is 10. Or at least there's plus or minus values here. The principal root, we call it. There's the positive version that we often just assume is the only one, because many times the negative roots don't make sense in the context of nature. Okay, so square root of 90 is somewhere between 9 and 10. It's slightly closer to 9 than it is to 10, so we'll call it 9. Square root of 169, if you happen to know, is 13, so we'll put our plus or minus because it's a square root, and 13. X squared equals 400. That happens to be 20 squared from our table there, so that's plus or minus 20. Square root of 30 is between what? Well, it's between the square root of 36 and the square root of 25, so it's between 5 and 6. Root 25 over root 36. It doesn't say it that way. If you remember from our last lesson, this is actually a different example, so I'll write it over here so we don't get confused. If we had 3 over 4 squared, we would actually square the top, 3 squared, and the bottom, 4 squared, separately. Likewise with square roots, if you have the square root of 3 over 4, you would square the top and the bottom separately. So we have the square root of 25 over 36 is actually the square root of 25 over the square root of 36, which is 5 over 6. Likewise for this guy, we'll square root both sides to get x by itself. The opposite of square is square root. Square root of 36 is 6, and the square root of 81 is 9, so we get 2/3. What whole number is the closest approximation to root 50? Well, root 50 is very, very much slightly bigger than 7, so once again, we've already done this problem. It is slightly more than 7. Okay, cubed roots now. The cubed root of 8 is 2. Yeah, and these ones are easier if you just have them memorized. I have some in this table here. The cube, 2 cubed is 8. The cubed root of 27 happens to be 3, and the cubed root of 64 is 4. The cubed root of 125 is 5, right here. But this one we're doing it a little bit trickier. If x to the third equals 1 over 125, then what must x equal? Well, answer, we need to cubed root both sides. So we're going to cubed root the left and cubed root the right and get 1 over 125 cubed rooted. So the cubed root of 1 over 125. Doesn't that sound fun? Not a pretty number. Whatever it is, I don't care. The area of a square is 144 square inches. What is the length of each side? I think we've done this enough to know that's 12 inches. All right, the area of the top face of a cube is 9 meters squared. What's the volume of the cube? This is a fun problem, actually. Let's draw a cube. Man, I'm good at drawing cubes. So here's my cube, complete with a little bit of shading to make it look nice. The area of the top face is 9 meters squared. That means that this side length is 3, and this side length is 3, and that's in meters. How do we find the volume? For a cube, it turns out volume is side cubed. Wonder why. So we'll take 3 times 3 times 3, or 3 cubed, to find the volume of the cube, which is 27 meters cubed. 27 cubic meters. All right, another cube question. We have the length of each side of a cube is x centimeters, where x is an integer. Dun-ba-da-dum. Looks like that. This is x, this is x, this is x. Okay. Why can't the volume of the cube be 15 centimeters cubed? Let's answer that question. First of all, the volume of a cube is side cubed, or in this case, it's actually going to be x cubed. What's the answer? Well, if you look at our table here, there's no 15 for integer cubes. It doesn't happen. So we can respond that for integer x, or rather there is no integer x. Let's type it that way. There is no integer x such that x cubed equals 15. It doesn't happen, which is why the volume of the cube can't be 15 centimeters cubed. Notice that this is possible if x is a real number. It's definitely possible. But if x is an integer, which are countable whole positive or negative numbers, denoted by this German letter Z, if you remember. If x is an integer, this is not possible. I'll see you in the next lesson.